Hello, welcome once again to Esomnofu online math class. In this video, we are going to discuss a very important topic in mathematics known as quotient rule of differentiation. Kindly hit the red button to subscribe to my channel. It gives you notification whenever a new video is out. For you to have a good understanding of the concept we wish to discuss now, you need to have a background knowledge of the basics of differentiation, like the formula for differentiation. It will help you in no small measure for you to tackle derivatives like this. So before this, I'm going to give you a formula you will use whenever you are asked to differentiate any function as a quotient rule. But nobody will tell you in an examination that you should use quotient rule to differentiate. It is left for you to know when to use quotient rule and when not to use quotient rule. Remember, in your primary and secondary school classes, you were told that quotient is the result you get after division. Therefore, whenever you see a function that looks as if one of the term or expression is dividing the other, you now know that this is a quotient because it's a fraction. Okay, so since it's a fraction, you should now employ the usage of quotient rule. So we'll use quotient rule to differentiate this. Then quotient rule is telling us that dy dx, that is the rate of change of y with respect to x, is equivalent to v du minus u dv over v squared is the formula you use for quotient rule. Remember, this du is just the rate of change of u with respect to x. You can see it as du dx, while dv can still be written as dv dx. But to avoid ambiguity, that is why I reduce it to this form. So you can say that dy dx is equal to v du minus u dv all over v squared. When I was tender, look at what I used to remember this quotient rule, because sometimes the formula may seem confusing, sometimes it will not be so easy to remember the formula. Therefore, I always write, when I was tender, that dy dx is the same thing as, it's funny, bottom the top minus top the bottom all over bottom squared, multiplying the differentiation of your top. This means differentiation. So here, bottom the top means bottom, which is your denominator, multiplying the differentiation of the top, the numerator, minus top again, multiplying the differentiation of the bottom all over bottom square. That's just the concept. Okay, so the first step you take is to say, let v be your denominator. It must be your denominator. So let v be x squared plus 2 here. So x squared plus 2 is our v, and u will be the numerator, 3x minus 5. That's our numerator, 3x minus 5. Now, you need to get the u and the v because v and u has been got. So the items left here is to get your dv and du. So let us get the v. The v means differentiating v with respect to x. So dv dx will be differentiating this x squared, and from the formula for differentiation, the 2 will come to the back, x, 2 minus 1. You always remove 1 from the power whenever it comes down. So we have it as 2 coming down, x, 2 minus 1. The derivative of any constant is 0. Therefore, our dv dx will be equivalent to 2x, 2 minus 1 is 1, and 1 is nothing, plus 0, and 0 is also nothing. So I've got my dv dx as 2x. Remember, this dv dx is serving as our dv here. So let us get du dx. That is differentiating this u with respect to s. Du over dx will give us, the power here is just like 1. It will climb to the back. We have 3 times 1, which is 3x, 1 minus 1, because you always remove 1 from the power, then minus 0, because when I differentiate a constant, I'm getting a 0. Therefore, du dx will give me 3x power of 0, because 1 minus 1 is 0. And anything power of 0 according to the laws of indices is 1. So I'm having 3 times 1, which will give me 3. So my du is also 3. Now, you can then apply the formula for quotient rule and get your answer. dy dx is equivalent to v du. My v is x squared plus 2. So under v, you plug in x squared plus 2, multiplying du. My du is 3. You can enclose it, minus u. Seeing my u, I'll plug in 3x minus 5. That's my u. Then multiplying dv. My dv is 2x. That's dv dx. That's my dv, 2x. So I'll put 2x here. All over v squared. V is x squared plus 2. So you have x squared plus 2 all squared. No need to expand this bracket here unless you're having a similar term up here that it can cancel. So dy dx will give us 3 times x squared is 3x squared plus 3 times 2 is 6 minus 2x times 3x is 6x squared. 2x times 5 is 10x all over x squared plus 2 to the power of 2. You continue again to collect like terms. So we have dy dx will give us 3x squared plus 6. The negative sign here will affect everything in the bracket. We shall get minus 6x squared minus minus turns to plus 10x all over x squared plus 2 to the power of 2. Now collect like terms. dy dx will give us 3x squared minus 6x squared is minus 3x squared plus 10x, then plus 6 here all over x squared plus 2 all to the power of 2. So at this stage you can simplify further, and this is your derivative, the required derivative. So you can see now that there is no big deal in quotient rule. It's as simple as that. All you need to know is to have the basis of differentiation, so that at this point in time you apply the knowledge of differentiation in getting your v and u. Then you differentiate v to get the v and differentiate u with respect to x to get the u or the u dx. Then plug into this formula, simplify, you get your answer. If you enjoyed what you've watched, kindly hit the red button to subscribe to my channel. It gives you notification whenever a new video is out. Thank you so much for watching.